Hi, yeah. So I'm Ben Oldfrey. I'm going to be talking to you about local production and innovation ecosystem building. And I'm going to sort of jump right in with the ideas. And I think hopefully within about 30 seconds, you'll probably know what I'm about. And then we'll move on to to other members of the team to talk. So globalization, particularly the pairing of mass production and global supply chains, is a hugely effective model for the provision of manufactured goods. It's been vital for technological advancement, and it's certainly vital for the assistive technology provision systems. In terms of reaching the masses, reaching the volumes around the world, it's absolutely critical. However, there's a catch. The monopoly that globalized mass production now has, with one-size-fits-all solutions, limited access to parts, barriers to repair strategies, barriers to refurbishment strategies for children, for example, context-specific innovation. This all makes more local service provision elements harder to implement, optimize, or improve for many low-income countries, and for many high-income countries as well. So more recently, with the fragility of supply chains being exposed during the COVID-19 pandemic, many people strongly believe that now more than ever is the time to re-examine where more localized product and service innovation that complements global systems could unlock more sustainable and resilient AT ecosystems. And that word complement is really important because it's not global versus local. The point is that we need both, and we need to look at what's appropriate for both models, for either models. Okay. So with this project, we're looking to bring together local and global expertise working in the AT sector to identify routes that could unlock local production, the local innovation teams that would enable it, build the global local ecosystems across peer communities and otherwise that could support them. So we've begun this work in Nepal, and I'll set the scene a little to explain why. So we've been discussing these issues for some time, and then during COVID, GDI Hub joined forces with other partners on an emergency UK aid programme looking exactly at this, at local production, but of medical devices for the communities around the world that were being so badly let down by the global politics at the time. Particularly the inequalities around vaccines. I know for me, it was one of those times when I haven't been more, in recent history, sort of quite ashamed of being British and seeing the sort of the inequality that is just right front and centre and not even hiding in terms of distribution of products. So most of that work was in 5 African countries, and there's excellent work done there, and we'd like to be building on that as well. But to cut a long story short, one of the innovators that we worked with was Xena Technologies in Kathmandu. So they rapidly innovated and produced tens of thousands of quality products for the Nepali health system and was generally an outstanding partner in that program. And on seeing this quality delivery, using a blend of digital and traditional manufacturing, we knew we wanted to continue our relationship together. So the manufacture of products, however, wherever it happens, although it's the topic, it's just one piece of the puzzle. And since we've been developing a growing group of brilliant collaborators in Nepal, and you'll hear from some of these shortly. So Ramchandra Thapa, who you'll hear from, who's sat over there, he's the director of Xena. And he's also now, he wears many hats. He's part-time researcher at GDI. We saw his work and we weren't going to let him go. It's great that he's joined us today because he's also handing in his master's thesis tomorrow. So you'll hear from him. But he shared his idea with us for what he called the Enabling Fridays initiative. So Fridays in Nepal, they're traditionally freer, so people might have some time to give. And on that, we convened a series of workshops with a local stakeholder group from the AT and grassroots innovation community in Kathmandu to help us set the direction for what we could work on. We had some ideas, but we really needed to be developing this work program together. During this time, we also hooked up with Rosie Gowron, who's an occupational therapist at the University of Limerick. She also wears many hats. She's currently the clinical lead of the National AT programme in Ireland. And she'd been working on sustainable actions in AT provision in Ireland and elsewhere for many years, and she also became an integral member of our team. So from there in this community, we built a fledgling innovation team, which includes Kathmandu University Design Lab, Limcare Prosthetics, Bloom Park and Xena Technologies, all of which reside in Kathmandu. So what we've got there is we've got local academia local clinical expertise, a local OT centre, occupational therapy centre, sorry, and local industry, along with the users themselves on the cases I'll explain shortly, all working together on grassroots solutions. And everything you're listening today, the ethos, the plans, the long-term vision that we've devised together. But mainly the root aim that we're looking to work on is to try to identify ways that we can enable long-term development of innovation capability, so its impact can keep building and not get stuck. This is tough, and it requires small steps. So we have a few streams of work currently. So one on bespoke product development. Now, we know highly individualized and customized needs are a particular area that global markets, they don't address well at all. They can't. If something has to be made completely bespoke from scratch, it can't be imported. So we're looking at a set of cases where we're co-designing products locally with users, or actually in most cases they're potential users of assistive technology, that address an individual user need that's often left unprovided for, or if it is addressed, it's at great cost, with the long-term goal of working out how service elements that incorporate local industry ecosystems could do this in the future. Critically, the individuals involved will be engaged and supported for at least 2 years so that a true understanding of what is needed from their perspective can be made clear. So, how to address the personal needs of individuals. How can we achieve quality throughout these processes, including ongoing maintenance and repair, which is often ignored, especially in the data. These need to be investigated, as well as understanding how global expertise, both institutional and from peer communities, can efficiently enable innovation. From various work of 80-20 30s and work that we see elsewhere, what we see is great ideas, but a real lack of tangible data on the outcomes that often come out from these of early stage projects. And that isn't always the fault of the people involved. It's really hard to actually put in the mechanisms in place to be able to collect that data if you're on limited funds. But we see this as a major contributor to many great ideas not getting much further than the starting block and being matured with further funding. Further funding is vital, but decision makers need evidence in order to distribute it to the right places. And to state on this one, we know these aren't the most pressing needs in terms of volume, but they are a very clear, unaddressed need now, and also a way for us to develop and optimize our ways of innovating product service offerings and prove that efficacy. So Amit, Ganga and Pratishthit, who I'll introduce shortly, they're going to focus on this work for us in a second, as well as their own personal reflections more broadly. So the second work stream to mention is around manual wheelchairs. So these are sorely needed in Nepal, they're sorely needed in a lot of places, and they're an obvious high priority. But before more systemic innovation can proceed in that space, much more data on the situation is needed if we're to do something useful. So we're working on a situation analysis of manual wheelchair provision, for which we've done some preliminary work, but currently we're talking to the Ministry of Health about how to proceed best with that, because at the systems level, without their involvement, we'd have limited success. But after this, we hope that sustainable local actions around wheelchair provision will be a major focus for the next phase of work. And our newer third work stream on repair and life cycle has come up. Now, repair and life cycle came up a lot during the Enabling Fridays conversations. They come up a lot in our conversations in general. And a recent fledgling work stream looking at spare part production is underway that we feel is likely relevant to many contexts globally. So Ram's going to discuss the other two work streams after the team. So so I've spoken plenty, and it's my pleasure to hand over to Amit Ratna Bhattacharya, our clinical lead on this project, who, he has extensive experience in the prosthetic and orthotics sector in Nepal.
Today I'm talking about the project we are doing with the University College London and its possible impact on innovation of ET in Nepal. So hope you all have heard about Nepal. It is the middle income country based in the Himalayas. If we talk about the health needs in Nepal, it faces significant challenges in addressing the health needs of people with disabilities. Access to healthcare services for disabled individuals limited even in the central and the provincial level. From few years, Nepal has started to realize assistive technology is crucial in rehabilitation. It was after 2015, that was after the mega earthquake happened in the Nepal. Government recognized the urgent need of rehabilitation services. The government understood that it is crucial to assist people with disabilities, but they didn't completely understand what rehabilitation in the healthcare field actually involved. Initially, their main focus was on physiotherapy because they understood rehabilitation is just a physiotherapy that at the time. So, however, after the Ministry of Health and Population assigned the leprosy control and disability management as a unit to handle disability-related matters in the health sector, they are actively forming the programs that create an impact in development of assistive technology. Recently, a global report on assistive technology has also made the 10 important recommendations. So we all know that for countries to get ready and has asked for cooperation. It's important to know that reaching this goal requires the visionary political strategies in the countries, and implementation mechanisms should be there, and research in appropriate technologies need to be carried out. Currently, even the basic raw materials and technology is not available in the country, and there isn't any effort made to be identified by the stakeholders working over here in assistive technology. So we know that it is always difficult to sustain long way by increasing dependence. It's been 20 years I have completed in this field, but I have not seen any significant changes to make an environment of sustainability despite huge investment for the service delivery. That's why still people need to pay from their own pocket for accessing the assisted product services. Recently, as the country is transferring to federal system, the Social Welfare Council has allocated some budget for free services to selected service providers, and even the local government have also started providing certain financial support. But there's still a lot of work that needs to be done to develop the mechanism and systems for achieving universal health coverage in assistive technology. So we perceive it is as a model to in the country that we are trying to do something together with University College London. We are developing the practice of using locally available technologies and exploring technologies with local engineers, clinicians, and users with international experts. So our team is currently involved in two projects. The first project is focusing on creating a partial hand for an 18-year-old man who lost his hand due to the industrial accident. So in this type of amputation, achieving the strong grip is the most challenging aspect, while technology in advancing rapidly in industrial countries like with bionics and myoelectrics. But here our goal is to find a personalized solution with local technology that can restore hand function based on the activities that are most important as per the patient. The second project is 53-year-old man who experienced a chopard amputation as a result of diabetes. The chopard amputation here means the surgical procedure where the foot is amputated at its uppermost part with his heel remain in the place. Although various prosthetic options exist for this level, but here our mission is to develop a digital intervention tailored precisely to the functional needs prioritized by the patient himself. And additionally, we will be conducting a comparison between the traditional prosthetic options that we are commonly making here in Nepal with this new intervention. In all this development process, we are also collaborating with the patient on co-designing. Actually, we think that for sustainability, the countries need to become more accustomed to local technology, following technological advancement in the world. So when it comes to assistive technology, people in Nepal can know much more about it, and there are not enough medical experts or researchers who are doing work on assistive technology. So we have just 12 registered prosthetists in hospitals, and engineers are not much exposed in this area of ET. So Nepal faces a significant deficit in educational resources and basic knowledge about assistive technology. So in conclusion, I would like to emphasize on improving our thoughts in making technology appropriate rather than just fulfilling the need by importing it from the outside. So I would like to say again, it is not just about the production of the device. We perceive this project as an opportunity to establish a model for creating a domestic resource finding system within the nation. So the network between the researcher, clinician, engineers, and users can establish a good system of sustainability. The international scholarship grant fund and collaboration, providing for low middle income countries, should invest on education, research, and on creating the mechanism to digging out the local resources for assistive technologies for self-sustainability in the low middle income countries. Thank you.
Thank you so much, Amit. Brilliant. And then, so now we'll hand over to Ganga Gurunga. So Ganga is an occupational therapist in Nepal. She's the secretary of the Association of Nepali Occupational Therapists. She founded her practice, Bloom Park, that already produces a range of therapeutic aids for children with intellectual and physical disabilities that it wasn't viable to import the equivalent products from elsewhere. And just to state, as an OT, we see there's a slight lack of inclusion often of OTs, PTs in the innovation process, and the input that they give on the design of products is becoming to us much clearer that it's absolutely critical. Over to Ganga. Thank you very much.
For almost 5 years in Nepal. The scarcity of therapeutic equipment and resources for the children I worked with inspired me to establish a company, Bloom Park, 2 years ago, which imports as well as develops physical, sensory, communication, and cognitive assistive products locally for children in Nepal. I am dedicated to the promotion and advocacy of occupational therapy in Nepal as a secretary for Association of Nepal Occupational Therapists. In Nepal, with a total population of around 30 million, 2.2% of people have some form of disabilities. Given our geographical and economic scenario, the need for local production of assistive products is high. A country where healthcare and technological innovation are just advancing, there is an opportunity to develop a person-focused sustainability approach from the outset. This is a time when innovations in assistive products are on the rise. The individual needs, wants, expectations are often left behind. Occupational therapy here plays a key role in advancing appropriate assistive technology provision, as occupational therapy is a person-centered health profession with a unique focus on the therapeutic use of everyday life occupations with persons, groups, or populations for the purpose of enhancing, empowering, and enabling participation, health, and well-being. Occupation relates to every aspect of daily living within the context or environment it happens. With only 9 OTs currently working in Nepal, today is an opportunity to highlight the importance of our role in assistive technology provision to meet people's needs now and in the future. There's a critical need to develop occupational therapy in Nepal. Occupational therapy brings in a unique perspective where the person is the center of the bespoke product development, taking into account a person's intrinsic and extrinsic factors for physical, psychological, social, environmental, and spiritual elements, which influences their occupational performance, what they do and how they do it, and the individual's readiness to accept their situation or disability and make informed choices and take control of what is important and what will meet their goals and aspirations. With the guidance of occupational therapy professor, Dr. Rosie Gurung, I am working collaboratively with the team with specific focus on person-centered, goal-oriented, and graded approach to co-produce bespoke product provision, follow-up, and therapeutic management, where the person's current and future needs are taken into consideration. When working with someone who has sustained an illness or injury that impacts on their everyday activities, it is important to understand this impact from their perspective and work together to identify and prioritize goals that are achievable. We do this by understanding that person's narrative or story, the context or environment in which they live and work to match solutions into everyday living. at the right time with the best solution and the built-in follow-up mechanisms to support successful assistive product use, which promotes sustainable use of the assistive technology that is meaningful and fulfilling to the individual's life. It was important to build rapport with the individual and their family by meeting them in their environment at home or their workplace, conducting an individual interview to understand their situation from their perspective, their everyday life, contexts, performance patterns, values, and interests. This creates an occupational profile, working together to prioritize desired goals related to their quality of life, health, and well-being. Then, synthesizing information from the person's occupational profile, we worked with the individual to identify the impact of their disability on daily living activity engagement while identifying the psychosocial, socioeconomic, environmental barriers. This was achieved by using an occupational therapy model of practice, PEOP, person, environment, occupation, and participant, and outcome measures, COPM, Canadian Occupational Performance Measure, and the FIM, Functional Independence Measure, alongside specific functional assessments. It is important to understand the person's readiness to accept their disability emotionally and psychologically, and seek to put in place or link with relevant education, counseling, and psychosocial supports alongside the provision of the bespoke product. During the product co-design process, as the occupational therapist, it was my role to assist the team to ensure the design was in keeping with the person's priorities, their real goals and desired outcomes they want from the product, to enhance acceptance and to reduce the risk of abandonment. A therapeutic intervention plan is designed addressing not only physical interventions and prosthetic management, but by restoring or modifying daily living activities, education, and training as integral to a person's overall well-being across the life course. As part of the occupational therapy process, we will set up a follow-up strategy for a sustainable use of the assistive technology and connecting, for example, with peers for peer support groups for a real sense of belonging, which can enable the process towards success. Co-designing in keeping with the person at the center of the product development process can truly benefit all of the interdisciplinary team, enhancing given the ability to choose an appropriate product according to lifestyle ongoing needs. Thank you very much.
Wonderful. Wonderful. Thanks so much, Ganga. And so our next speaker is Pratishthit Lalshrestha. So Pratishthit is an assistant professor at Kathmandu University. He's the head of the design lab there that works on a range of products in the rehabilitation space. So Pratishthit has kindly recorded his talk for us, and hopefully that can be aired now, because he was concerns over whether he'd be able to make it. It's actually quite late in Nepal, so thank you so much to all of our speakers, but Pratishthit's family is a little bit ill. So hopefully we can go to Pratishthit's video. Thank you very much.
Namaste, I'm Pratishthit Lalshrestha, Assistant Professor at Kathmandu University, Nepal, and Principal Investigator at Design Lab. So at Design Lab, we are trying to develop technologies and devices that can address specialized issues related to rehabilitation, healthcare, and assistive technologies, especially for countries like this, countries with low resource settings like Nepal. We have limited industries that are working in this field, and very few research are being carried out in universities or research centers to identify issues or develop technologies. Local innovations are done, but very limited, and may die out even without reaching the actual users, or as industries either are not aware about it, the innovation, or may not have confidence to use the innovation and a lack of proper validation. Industries have no other choice than to use the technologies that are imported, which may not be designed based on the local requirement. It'll be mostly standardized and off-the-shelf products. So these are a few issues with the device development or innovation in countries like ours. We do develop devices that addresses the local problems, but the issue is with validation and availability of proper resources. This is where global network can come in and help mitigate the problem. For example, we have been working on mechanical prosthetic knee joint with concept of mixed manufacturing technologies, using conventional manufacturing technologies and relatively new digital manufacturing technologies. We have identified the issues, we have tracked the variables, we have designed as per the local need. We did the calculations and prototype it. So this is what it looks like. So some parts are 3D printed, some parts are made using traditional conventional manufacturing process. But now, when we need to validate it, we lack standard testing equipment. So to mitigate this, we could send the prototype to any institute outside our country that has the testing equipment or has the gold standard setup through this global network. Yeah. The device could be validated and then deployed not only in the local market, but also to the countries with similar situation. In this case, in this particular case, UCL and IIT Madras is helping us. Validation of developed technologies is, developed devices is one thing, but further developing the device is another challenge, as we need to understand the local need and then the settings where the device will be used. Developing a device to solve a local problem using local resources, man, material, machine, could be one method for sustainable design and development of the device. This is what we are doing with GDI Hub in a project. We're trying to utilize local manpower with local experts and manufacturers to identify and solve the problems. For example, there's a case of diabetic foot with a partial amputation of the foot. We as a university are collaborating with local prosthetic centers, occupational therapists, and manufacturing centers to develop a solution for this case, understanding the user's perspective. We are trying to design a foot with varying stiffness within, depending upon the distribution of the load and need for flexing. Manufacturing this with a conventional method may not be possible, but additive manufacturing and other digital tools may provide more convincing solution that addresses the user's need. So this is what we have been trying. This is the 1/5 scale of stump and the design prosthetic foot. Similarly, this is the 1/2 scale of the foot that we have designed, and it's printed with TPU, flexible material. Similarly, another case is for the amputation of upper limb, palm. A young boy with a dream to drive heavy vehicles professionally. So we are using similar methods to develop a local sustainable solutions for him as well. Further, we are testing the temperature monitoring device, which can be placed within the prosthetic socket, which will continuously monitor the temperature of the part covered with the socket. It's a tiny device. Which can be programmed and record data for 9600 iterations. Which means if we set the measurement gap of 15 minutes, then it will work for 100 days. It will keep measuring for 100 days. Just to test and understand its uses, we have printed a wristwatch band with a slot of the timer in it. And I have been wearing it since past 2 weeks, 24/7. Here we have placed a sensor, and then this is the band. It keeps measuring the temperature of my wrist. So this is how we are breaking the boundary between the countries for developing sustainable local solutions. Thank you. Namaste. Thank you. Namaste.
Brilliant. Thank you so much, Pratishthit. And him stating there that, yeah, I mean, problems just in testing anything at all, but as Pratishthit's saying, you know, even just testing the test equipment that we might need for quantitative use measure there is really important. There's so many different complexities to innovation. So finally, it's my great pleasure to hand over to Ramchandra Thapa, who I've absolutely loved working with for a number of years. As I said, Ram is the director of Zena Technologies in Nepal, who make a range of products already. We then sort of on Ram coming to study for his master's in the UK. We also have Ram as a part-time researcher at GDI, and just in any way possible, really, we're just sort of trying to keep hold of him. Over to you, Ram. Thanks. Oh, yes. Yeah, let's see.
So what has remained is to share my own story now. So hello, London. Namaste. Thanks, Ben, for the wonderful intro. I'm super thrilled to be here today to share my journey of social innovation all the way from Nepal. So let's jump back to 2015. I had just graduated with a mechanical engineering degree from a university in India, and a devastating 8 magnitude earthquake rocked Nepal. It claimed over 7,000 lives and caused massive destruction of properties. I empathize with the people of Morocco now who recently faced a similar tragedy. I can feel the pain they are enduring. So I left my comfy new job in New Delhi and returned back home. I felt this deep call to help rebuild Nepal, although I had no clue how to do that. But I just knew I had to be there. Back home, I started teaching science in a local school for just a few hours a day, because let me tell you, finding a good job were hard to find. The rest of the time, I was learning auto mechanics. It's tricky finding work you feel really passionate about in Nepal. But I was obsessed with the idea of 3D printing in Nepal because I was so much wanting to do that. So I started working with Feel Ready and ran a couple of workshops on 3D printing for humanitarian response for the first time in Nepal. Then we drove out to remote earthquake, which was destroyed by the earthquake up in the mountain near the China border. And together we used 3D printing to fix broken hospital equipments like water pipe fittings and spare parts for the beds, hospital beds, right there on the spot using 3D printers. My wildest fantasy was actually coming to life. I was pioneering 3D printing technology in Nepal through this amazing global collaboration. That moment marked the beginning of an unbelievable journey of innovation for me in Nepal. So after that, I joined Feel Ready as a humanitarian engineer, taking my 3D printing skills to the neighboring countries in Bhutan and Bangladesh. We trained young engineers, transfer skills, and set up labs to make essential items in their countries when a global supply chain breaks down after disasters. It's something really needed to do. So, because waiting months for imported parts just wasn't practical. So fast forward to 2017, we founded my company, General Technologies, which Ben mentioned, bootstrapping from just one busted 3D printer to a fleet of distributed manufacturing tools. After that, I joined Feel Ready as a humanitarian engineer. At my company, we do a couple of things. We try to do almost everything because that's what small companies does. But we mainly focus on the repairs, because fixing locally is way faster and cheaper for countries like ours than importing replacement parts. So one time, it's interesting. So one time an NGO called us about a broken medical suction pump, but the equipment importer refused to fix it. They wanted to make a greedy $150 selling a whole machine. So we drove 8 hours to the rural clinic with a 3D printer and solar panels. I've done that many times. Sometimes I run 3D printers from cars' batteries, and it works. So we designed, printed, and fixed the broken part in just an hour for a few dollars. Bam. Take that, overpriced importers. Another one was an efficient wood-burning cooking stove we designed and manufactured in Nepal. That stove has massively improved lives for over 50,000 rural families who rely on burning fuel. So less smoke, more safety. Local people would come to us very regularly asking if we could make assistive devices for them. And we tried that. We made various things for them, though the internet designs rarely fit with their unique needs. As a small company, we had limited expertise in assistive technology to make custom adjustments needed for them. We always thought we could do more, but we really didn't know how. Then there was COVID, and the pandemic was the most issue as the global supply chain come to a complete stop. Our distributed PPE production during COVID using 3D printing and local manufacturing was recognized by UK Aid, and that's when I met Ben. So we did that through the fusion of novel digital manufacturing and conventional manufacturing, like injection molding. We made several different items like PPEs, goggles, nasopharyngeal swabs, and many other things. So as Ben mentioned, we established the Enabling Friday community. That's the network. And we begin to know much about ET sector in Nepal and think about how different actors could come together on problems you have heard from some of our colleagues just before. I'm now embedded in the research team with GDI Hub and act as a researcher with the opportunity to conduct some of the most needed research on ET 2030 program. This journey, seeing how research and evidence is done, has given me a whole new perspective on what is needed to make bigger impacts. So we began to investigate wheelchairs. That was also the thing that I did for my thesis. And we have started to work on this. We have conducted a preliminary study on wheelchair provision in Nepal. We interviewed 14 stakeholders in Nepali wheelchair system, and we identified several challenges faced by wheelchair users and service providers in the country. So for the users, issues like inaccessible infrastructure, you don't be able to walk in the pavements in Kathmandu. Lack of awareness, people are not aware of different types of products and different types of disabilities, high cost of product, and scarce availability of suitable wheelchairs severely restrict their mobility and independence. So service providers face different hurdles, such as insufficient training opportunities. Most of the service providers we interviewed, they went to India and other countries to receive trainings, but there are only few trained professionals. Product scarcity and complex import regulations and difficulties with repair and maintenance are the major issues to service providers. So frequent breakdowns occur due to lack of spare parts and due to lack of skilled technician to fix the wheelchairs. So more than 50% of the wheelchairs in the developing countries gets unused because it either doesn't meet the requirement of the user or it gets broken down in 3 or 6 months. And you can fix it because you don't get spare parts. So we have planned for this work, we have planned how this work can become a larger, more useful piece to eliminate the wheelchair system in Nepal. We are also trying to make clear for all the opportunities in local production ecosystem, like what we did earlier. We have begun trying to map this with interviews with 9 local manufacturers in Nepal to characterize local production capabilities in diverse materials and technologies. So we want to expand this mapping to see how we can act as a system, not just working alone, like not just engineers, not just working as an engineer and health professionals, not just working as a health professional. So bringing everyone together to work in these problems. So we interviewed CDCA, the Center for Disabled Children Assistance, who work on wheelchair distribution programs in Nepal. CDCA is a major distributor of wheelchair in Nepal. They receive around 250 to 300 wheelchairs every year on a regular basis. So during the interview, CDCA identified 5 spare parts which would require frequent replacement as they wear out during use. So a follow-up visit to the wheelchair facility was made to understand the nature of parts and components and how they interact with the major component of the wheelchair. These components were plastic parts and they possess very low risk to user, but were very important to maintain functionality of the wheelchair, to ensure its safety and durability. Although many other parts such as caster wheel, armrest, footrest, seating, and the tires were also of high interest. These 5 simple components were recommended by CDCA for the pilot, considering its manufacturability and the time limitations. Although some limitations persist in terms of materials and technology, we can supplement these with the network of conventional production process like injection molding and casting factories in Nepal, which does exist, and just few people know that. However, quality control infrastructure and vocational skills need substantial improvement because that's the missing bit. So while technology is just one piece of innovation puzzle, as Ben mentioned, a motivated and dynamic team is the key, like we have here. So with GDI Hub network and local partners, our actions are fortified by global local systems thinking, and we are pushed for future progress. From my more recent experiences, working in the research and working on my own thesis, working more in depth in the AT sector, it seems that there is a wealth of overwhelming information and policies on assistive technologies, disability rights, and global development. Yeah, but what truly makes a difference is taking small actions with the potential to scale. That's what I feel. With the GDI Hub and our ecosystem, we are striving to do just that. So I hope it inspires you to take small actions that can make a big difference in our world. Keep dreaming, keep creating, keep making things, and maybe one day your fantasy company will become a reality too, like mine. So namaste, and see you again.
Brilliant. Thank you so much, Ram. And that brings us to the end of this session. And I don't know what happens next, so I could keep talking. Oh, good. There we go. Someone's told me.
Takes the stage.
Brilliant.
Brilliant. So we were.